Hello everyone. So today we are going to look quick sort and it's working. So firstly we have given an vector or array which contain element 8, 5, 1, 3. So what we have to do is we have to apply quick sort. So what quick sort algorithm do is it firstly select a pivot element and then it divide the rest of the list such that the pivot element placed at its correct position. So let's suppose 8, 5, 1, 3 are there. So basically 3 is greater than 1 and less than 5 and 8. So 5 and 8 goes here and then 1 comes here and 3 is at its right position. Now since this is a single element, it's automatically sorted. And now if we talk about this, then what we have to do is we have to again apply quick sort here. So what we have to do is this is the pivot element now, and we have to partition the remaining array such that pivot element is at its right position. So basically 5 goes here and 8 comes here, right? So now as we can see, now our overall array is sorted. So this is how quick sort works, but finding the correct position of the pivot element, we have to actually apply a second function which gives the right index of that particular pivot. So let's suppose we can see it here. So let's suppose 8, 5, 1, 3 are the elements of our array, right? And what we do, we initialize I as a value that is L minus 1. So L is basically 0. So I is initially L minus 1 and J is at this position. Now what we do, we compare the element at J index with the element at pivot. So this is pivot. So what we check, if our value at J is less than the pivot, then what we do, we just swap vi with vj, and if this is not the case, then we just simply increase our pointer of j. So here we can see that this is not the case, so we just increase our pointer here. I is here itself and j comes here. Now also the index is 5 and the value at index p is 3, and 5 is greater than 3, so we simply increase our counter j. Now once we reach here, so at j the value is 1, at p the value is 3. Now the value at j is less than the value at p. So what we do, we firstly increment our counter, that is I comes here. Now what we do, we just swap the value of I and j. So after swapping, what we got? We got that 1 comes here, 8 goes here, and then 5 and 3 are as it is. Now after doing that, what you can see that now we cannot move j further because the pivot element it's already reached. So what we can see here now is that I is pointing at this index and the pivot element is here. So we can see that this I is the minimum element, that is smaller than the pivot element. Rest all of the elements are greater than the pivot element. So what we got is that the correct position of our pivot element is at I plus 1 index. So we simply return this I plus 1, and before that we swaps the value of the pivot and I plus 1 index. So that is we got 1385. Now we come and check for rest of the subarray, that is 8 and 5, and we apply the quick sort here. So this is how the working of quick sort actually happen. Now let's try to code it. So here firstly a void function is created, name quicksort. So it has array left and right. So what we do, we just do this quick sort only the element inside our subarray is greater than 2, because once it's become 1 we don't have to compare it actually. So here p is basically the partition function which actually gives the correct index of our pivot element, and then we again call our quick sort for rest of the array, and then that is the left side of the array and then the right side of the array. That is, let's suppose here 3 is the pivot element, so we have to again call the quick sort for this function as well as for this part of the array. So after doing that, we are done. So now let's see the working of this partition function. So what it does is, it has an element, it has an pointer I which is l minus 1, and here pivot is basically r minus 1, that is the last index. Now what we do, we uh, we uh, we run a loop j which goes from j equals to l till r, that is it actually goes till r minus 1. And what we do, we actually check if array of j is less than the element at pivot. Then what we do, we increment our I counter and then we swap the values, and at the end of this we get an index I plus 1, before which all the elements inside our array is less than, and after which all the element inside our array is greater than that element. So we return I plus 1. So this is the working of quicksort. Now let's try to run this. So this is an unsorted array and we are going to sort it using quicksort. So you can see now the array is sorted. So this is the approach to solve or to apply quicksort algorithm. And if you want to access the code, then you can check the GitHub link given in the description. And this is it for this video. Thanks for watching.